Okay, so we finished doing our calculations for the titration of a weak acid with a strong base. If you recall, we were titrating benzoic acid with potassium hydroxide. These were our calculations for the pH at different points in the titration. And what I want to do now is plot these data. Just like we did for the strong acid, strong base titration, I want to plot on the x-axis the volume of strong base that I'm adding from the burette. And on the y-axis, I want to plot the pH values that we calculated. So to do this, I plotted these values in Excel. And again, you can plot them in Excel yourself, or you can try just freehand sketching them using graph paper. But here I've just input those exact values from the chart that we generated into Excel. Here are my volume of KOH in milliliters and the pH values that we calculated starting at 2.6 and going all the way up to 12.5. So I plotted these data with the x-axis, with the volumes on the x-axis and the pH values on the y-axis. And here is what my chart looks like for the titration of benzoic acid with potassium hydroxide, both 0.1 molar concentrations. So here I have my pH, and here I have the volume of 0.1 molar KOH that I have added. So there are several interesting points in this pH curve that you should be able to identify. Here, this kind of zone where it's pretty flat at the beginning is known as the buffer zone in the titration of a weak acid. It would be the same for the titration of a weak base, except it would be up here, right, going down. The buffer zone is anywhere where I can use the Henderson-Hasselbalch equation, anywhere where I have the weak acid and its conjugate weak base both present. An important point in the buffer zone is this point, which you may remember is the half equivalence point. The half equivalence point is the point at which pH is equivalent to the pKa of the weak acid. And you'll notice that that was at 25 milliliters. So the equivalence point itself is midway up this rise. And notice the equivalence point was at 50 milliliters. So the half equivalence point was literally at half that, 25 milliliters. Okay, so that's what half equivalence means. So the equivalence point is midway up that kind of jump there. And really, if we remember looking at the pH value for the equivalence point, it was 8.4. So the equivalence point is where we have weak base controlling the pH of the solution. So in the beginning, we just had weak acid. In the buffer zone, we have the weak acid along with the conjugate weak base. And at the equivalence point, it is the weak base that is controlling the pH. Beyond the equivalence point, we still have weak base, but it's really the hydroxide, the excess hydroxide, that's controlling the pH of the solution. And as you can see, eventually we kind of level out. So we had 12, and then much later we have 12.5. So we have this kind of plateau in any pH curve here. Now, if you were titrating a weak base with a strong acid, it would just look like the inverse of this. But you would still have the buffer zone. You're in the titration of a weak base, at equivalence, you would have a weak acid. So you would have an acidic pH. And then you would have hydronium start to control the pH. So you should be able to sketch pH curves like these. I hope that this makes sense.